Hey guys, so you should have completed these problems and gotten two graphs that look something like this. So let's examine the first graph. We have the graph f of x equals x squared minus 4 all over x minus 2. So if I went ahead and factored that in the numerator, I would get x plus 2 times x minus 2 over x minus 2. The two factors of x minus 2 would cancel, and we would get x plus 2, which is just the graph of a line. However, it's undefined when x is 2. And that's because a value of 2 will make the numerator 0. So we obviously know that we can't divide by 0, so that's why our graph looks like this. So what is f of 2? Well, f of 2 is undefined because it would make the denominator 0. But if we completed a table of values to see what was happening as x gets really close to 2, if you filled out the table of values here, you would see that as we get closer and closer to an x value of 2 coming in from the left, right? So as we're coming in from this side, the function wants to approach a y value of 4. And then as we come in from the right, as we're just a little bit above 2, we're coming in to 2. The y value that the function wants to approach is 4. So while f of 2 is undefined, the function really wants to approach 4 as it gets very close to 2. So we would say that the limit as x approaches 2 of x squared minus 4 over x minus 2 is equal to 4, because that's the y value that the function really wants to reach. So think about limits like where the function wants to reach. Look at example number 2. You should have sketched this nice rational over here. We are going to have the limit as x approaches 2 of 1 over x minus 2 plus 3, that limit is not going to exist, or we say DNE does not exist. And here's why. So let's look at f of 2, right? What is f of 2? F of 2 is undefined because f of 2 is an asymptote. It's not a point on the graph. If we completed the table of values below to determine what happens as x gets really close to 2, we can see that as we come in from the left, right? As we come in from the left and look at the values as we get very close to 2 on the left-hand side of 2, we would see that the function or the graph is heading towards negative infinity. It's going down, 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 down without bound. And then we would say that the function or the y value is trying to get to negative infinity. So if we wanted to use limit notation, we would see that the limit as x approaches 2 from the left, this little minus sign up in the exponent means from the left, f of x is approaching negative infinity. If we examined the limit on the right-hand side of 2, coming into 2 from the right-hand side, the function is increasing without bound. It's heading up towards positive infinity. So we would denote that limit as the limit as x approaches 2 from the right of f of x is equal to positive infinity. So since we have the function trying to get to two different y values on either side of the vertical asymptote, we would say that the limit does not exist because we can't see, are they trying to get to the same place at 2? The function is not trying to get to the same place at 2. One side's going all the way down, one side's going all the way up. So we would say that the limit as x approaches 2 of f of x does not exist. So we have just examined the two sides of a value. So the definition of a limit as x approaches a, the limit of f of x is L, written the limit as x approaches a of f of x equals L, right? So this is just kind of going over the notation that we would use when we talk about limits and writing limits. This piece here is going to be the function, right? The limit as x approaches a of f of x. Why did that point in there? Oh, I'm on ink to shape. Sorry. This is the function. This is the limit, or the y value the function wants to get to. And then a is just a number. So if all values of f of x get close to L, or this number, this limit, when x is sufficiently close but not necessarily equal to a, we would write the limit as x approaches a of f of x is equal to L. This sounds very like semantic-y. You're probably like, huh? But let's do a few examples and hopefully it'll become a little more clear. So using the graphs and or tables from the previous examples, find each limit. Part A, the limit as x approaches 2. Notice here that they don't distinguish if we are approaching 2 from the left or the right. We're just looking as x approaches 2 of 2x minus 3. So let's go up to our graph, 2x minus 3. The limit as x approaches 2. So we would go to the value of 2 on the function, the x value of 2. We would go up to the graph and we would see that the y value of the graph when x equals 2 is 1. So our answer would be 1. In part B, we're looking at the limit as x approaches 2 of x squared minus 4 over x minus 2. That was the second graph that we did. We're looking as x approaches 2. So as x approaches 2, we go to 2 on the x-axis. We head up to the graph. The y value that the graph is trying to get to is 4. Does it get there? It does. It gets there on the left-hand side. It gets there on the right-hand side. It's not defined at 2, but the limit certainly exists. The function is trying to get to 4 as we come in on both sides of 2. The limit as x approaches 2 of this third piece, that was the third graph. So we're going to look and see what happens as we approach 2 from the left. The function is going towards negative infinity. As we approach 2 from the right, the function is going towards positive infinity. The limit from the left does not equal the limit from the right. Therefore, we say that the limit does not exist. If you wanted to see that in the proper limit notation, we would say the limit as x approaches 2 from the left of f of x is not equal to the limit as x approaches 2 from the right of f of x. Therefore, the limit as x approaches 2 of f of x, in this case this guy, does not exist. So go ahead and pause the video, read this sentence, and we'll meet back here in 2 seconds. Okay. All right, so welcome back. You should have seen that we are trying to look at some notation. When x approaches 2 from the left, we use the notation, the limit, as x approaches 2 from the left. This little symbol up there indicates from the left of f of x. When x approaches 2 from the right, we use the notation, the limit, as x approaches 2 from the right. So this little plus sign up in the exponent indicates the right direction. So using this notation, we can evaluate limits from the right or from the left individually. So we're going to use the graph from above to evaluate each limit. I'm going to do the first couple with you, and then you're going to pause the video and finish the rest on your own. So we have the part A right here. We have the limit as x approaches 0 from the right of f of x. This piece up here is f of x, okay? So we're going to go to 0 on the x-axis, and then we're coming in from the right. So we're going to go up to the graph and then just examine what's happening as we come into 0 from the right. What is the y value the function wants to get to? 1. Okay, part B. The limit as x approaches 1 from the left of f of x. So now we're coming into 1 from the left. So you're going to go to 1 on the x-axis. You're going to go up to the function, and you're going to approach coming in from the, from the left. So you're going to want to approach coming in from the left. So we are heading down, 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 down until about 0. So we would say that the limit as x approaches 1 from the left of f of x is 0. Part C, the limit as x approaches 1 from the right of f of x. So now we're going to 1 on the x-axis, and we are coming in from the right. So we're coming in from the right, and it looks like the y value the function is trying to get to is just plain old 1. So go ahead and pause the video and do D through I, and then check your answers when you come back. So pause. Welcome back. Did you get these? Great. All right. So here, for as we're approaching 4 from the right and 4 from the left, you could say that it's like approaching 2. So if you put 2 here for either one of these, that's totally okay. I was just like, oh, it's not quite at 2. I would say 1.9. But if you put 2, we're both thinking of the same thing. You're good. Okay, so when do limits not exist? Limits fail for a variety of reasons, all of which can we track back to the definition. The definition states that the limit as x approaches a is L, but L must be a real number. Limits fail when the function approaches infinity as x approaches a. When we built our tables, we looked at values of the function as x approaches a from both sides. Limits fail when the function approaches different values from the right and the left. Let's look at the last picture again. Okay. So what I really want you to think about here, right, is when you're evaluating whether a limit exists or not, does the limit as x approaches a from the left of f of x equal the limit as x approaches a from the right of f of x? If so, then the limit exists. And the way you can remember that is there's 2 sides to every limit. Like that old saying, there's 2 sides to every story. There's 2 sides to every limit. That's beautiful. I'm going to cry. Okay, so part A says the limit as x approaches 0 of f of x. Let's go to 0. Here we are. Okay. We have the function or the y value that the graph is trying to get to at 0 is 1. For B, the limit as x approaches 1 of f of x. Well, let's go ahead and see. As we get to 1, okay, there's something happening on the left-hand side and there's something happening on the right-hand side. So let's go ahead and evaluate what's happening on the left and what's happening on the right and see if they match. If they match, the limit exists. If they don't match, the limit does not exist. So let's see. The limit as x approaches 1 from the left of the function. Let's see what happens when we come in from the left-hand side as we get close to 1. Okay, the function is tending towards 0. Now let's look at the limit as x approaches 1 from the right of f of x. So we are coming in to 1 from the right, and it looks like the graph is at a solid 1. So since these two values do not match, we would say that the limit does not exist. Okay, the limit fails. The limit does not exist. Let's try part C. The limit as x approaches 2 of f of x. Let's go to 2. Oh my goodness, there's a bunch of crud happening at 2. So let's examine the limit as x approaches 2 from the left. Let's examine the limit as x approaches 2 from the right. And let's see what we get, okay? So the limit as x approaches 2 from the left. I'm coming in from the left, and the y value the function wants to get to is 1. Then I'm going to look at the limit as x approaches 2 from the right. So now I'm coming into 2 from the right-hand side, and it looks like the y value that we're trying to get to is 2. So since 1 and 2 do not match, we would say the limit does not exist. Also, let's just think about this for a second, right? What is f of 2? Okay, we know the limit as x approaches 2 does not exist because the function does not approach the same y value on either side of 2. However, what is f of 2? If we were to define f of 2, it would be this guy right here, which is like 1.5. So f of 2 is 1.5. I don't know. You don't need to talk about that when you're doing limits, but I just wanted to kind of like underscore the difference between the notation here and then the notation with these two guys. Interesting. So now let's look at the limit as x approaches 3 of d. Go ahead and pause the video, try this one on your own and see what you get, and then try e on your own and see what you get. So pause the video and I'm going to Cool. Did you get these two answers? Great. All right, and then we're going to, oops, don't look at the answers. We're going to do that in class tomorrow together. Okay? Happy limiting.